The developer experience of Windows is changing, embracing ARM processors, neural processing units, and all wrapped up in a recycled ocean plastic case. My guest today is an engineer who uses this new experience as their daily dev box. Let's get personal computing with Ivette Carreras. Hey, Ivette, welcome to Microsoft Reactor in Redmond.
Thank you. Thanks for having me.
Now, you brought a pretty cool device with you today, and I thought I might wear an appropriate shirt for this. So, this shirt is from one of the classic Intel processors, from the first computer that I had. And when I think back to the history of Microsoft, over the years, Windows has been based off these personal computers that have used the Intel instruction set. It's kind of that Intel architecture, whether it's the x86, the 32-bit one, or the x64, the 64-bit version. That's kind of been the history of Windows.
Yes.
But you're telling me you've got a Windows device that's got a completely different chip in it that's not an Intel chip.
Correct.
Okay, this is cool. Show me this device. Tell me about this device.
So this is the Volterra project device, and that's my favorite name. But
Volterra?
Yes, you might have heard of it as the Windows Dev Kit 2023.
That doesn't sound as cool as Volterra.
Right? That's what I thought.
That's cool. Come on, history. Why Volterra? What's the story behind this?
Honestly, I don't know, Jim, but I love the name.
It is a cool name.
It is, and so I loved calling it Project Volterra.
Okay, Volterra. That is what it is from now on. Yeah.
Yes.
What is Volterra?
So Volterra is our dev-targeted device for ARM development.
ARM development. So not like ARM development, but we're talking ARM as in the same chip I have in my phone?
Yes.
Okay, because ARM's been kind of on the rise a lot for phones. You know, it's a low-powered chip. So someone's literally taken a phone and made a computer.
Yes, so ARM is a type of architecture that is fairly new to, the market in comparison with, what we've seen from Intel, x64, and x86. And it is very power efficient. It leverages a new instruction set design, which is called RISC, which is very simple. And from that, it derives a lot of the power efficiencies that come with. So you're going to see these type of chips in your phone because you have to have a long running device for the day. You're going to see it in more and more laptops. And this device is what we have created for developers to be able to create new applications, to transition existing applications, and to run their developer ecosystem and workflows in a powerful device that is not battery based.
Right. Okay. So we've taken the idea that with my phone, as you say, the battery's got to last all day. So it needs to be highly power efficient. We've taken that chip, we've put it in a device that, again, is power efficient.
Yes.
So that people can build apps that target the same power efficient platforms.
Yes.
Which, I mean, is no bad thing. We live in a time of climate change. We need to reduce our dependency on a whole lot of power. So when we think about power efficiency, usually there's a trade-off. It uses less power, but it gives out less power. Is this just as powerful as we'd expect?
It is. It is very powerful. So this is the latest Qualcomm Snapdragon ACX Generation 3. So this is what you see in our Pro 9 for Surface devices. It is the same chip. It has CPU, it has a GPU, and then now it has an NPU.
An NPU?
Yes, so a neural processing unit. Neural network processing unit.
So CPU is your central processing unit. That's the bit inside there, the general purpose processor that runs it. The GPU is what makes games look cool. It's the graphics processing unit.
Exactly.
So that makes your games look cool. And we've seen a rise of that for running AI because 3D games is floating point math and AI is floating point math. But you're saying there's like a neural processing unit there.
Yes.
That's dedicated to doing AI workloads.
Correct. So the NPU is specifically designed to efficiently run AI workflows.
Right. Okay. So just think about this then. If we've got that separate from a GPU, because if I'm running AI on my laptop, I can run it on the GPU.
Yeah, or the CPU. Yeah.
If I'm running it here, I can actually have that running whilst using my GPU and the CPU and the NPU.
Yeah, so Jim, you can be in a place now where you're developing applications that can target workflows to each different component in the hardware to give the user experience the best possible outcome. So you're not taking away from the CPU or the GPU compute power. You're sending to be able to run AI workflows. You instead are sending it to the NPU specifically.
Okay, so just thinking of an example here. I'm a gamer. a very bad gamer, admittedly. I don't do multiplayer games, so I'd lose. But if I'm thinking about a game on here, for example, I would have the CPU running the core logic of the game.
Mm-hmm.
I would have the GPU doing all the flashy graphics.
Right.
And then when I have the AI, because a lot of games you're playing against AI characters, I don't have to take away cycles from the CPU or the GPU. I can run the AI on the NPU.
Exactly.
Nice. Okay, this sounds pretty cool from a hardware perspective. And can I pick it up and play
Yes,
it?
please go ahead.
And it looks pretty nice from a manufacturing perspective. So this is a very nice kind of case we've got going on. It's very lightweight.
It is.
And it feels plastic.
It is. So it actually contains 20% specifically ocean recycled plastic, which is really cool.
That is awesome. So literally, instead of we're generating more plastics that are going to end up back in the ocean, we're taking plastics out the ocean.
Yes.
Recycling this. That is really cool. So my daughter is absolutely obsessed with this. Whenever she can buy anything that's made from ocean plastic, she loves it. Like, yes, I want to take this. So this is, from that kind of ecological point of view, we're saying that this is using less power.
Exactly.
And we're actually taking plastic out the ocean. That's so cool. Cool. And it's a nice little small device. It's got all the ports you expect.
Yep.
All your USB-C ports and all your USB-A and all that. There's screws on the bottom as well.
Yes. So you would have to check on the warranty agreement, but you could potentially open it. It may be serviceable by Microsoft or other vendors.
Okay, but I need to check the warranty first for you.
Yes, please.
Oh, I was about to get my screwdriver out. Okay, cool. I mean, this is pretty cool. Should we plug it in and actually do some things?
Yes, let's do that.
Cool.
All right, Jim.
Okay, so this is Windows 11 by the looks of it. I recognize that little wobbly blue thing.
Yes.
And this is running on the ARM processor.
Correct.
Okay. Now, Windows 11 runs on Intel. So is this a special build for ARM?
Well, we do build for Windows for ARM, but it's just like what we build for Intel or AMD.
So it's exactly the same code.
It's the exact same code, but it is having some interesting magic going behind the scenes, which is our emulation layer for supporting x64 applications as is in the same Windows and ARM image.
You're serious? So
yes.
this is not just a magic just ARM only. You're saying this Windows 11
yes.
been built for this ARM device, but I can run something that's built for an Intel device.
Correct.
On this.
Yes.
That's just bananas.
It is amazing, isn't it?
Pretty cool. Okay, that completely changed it, because I was just assuming it was just an ARM device. You know, it's like I have an app on my phone, it will only run on my phone. But right. I can literally run any Windows application.
You can take any Windows application that was built for Intel or AMD chips, and then you can transfer them here and then just run them.
Just runs an emulation layer. I don't have to do any magic. It just
works.
Just works.
Yeah.
Okay. Does that mean then? I mean, you're saying this device, you use it for building for the ARM processors. So you were thinking about running workloads in the cloud on ARM chips to kind of reduce that energy dependency.
Mm-hmm.
But you're saying if I build something here, can I build it for both Intel and ARM? So if I can run Intel on here.
So you can have your full developer workflow in this device where you are building and targeting Intel chips and running it. Now you have to keep in mind you're running under the emulation layer. Mm-hmm. And then you can build your ARM version of the application as well and also run it. No emulation for ARM or nothing. So you can have your entire workflow of your dev experience in this device.
Okay, so that makes so much sense then. Why this is the dev kit. It's your dev loop should be I work on ARM,
mm-hmm.
and then I can build the other platforms from there. Rather than if I work on Intel, I can't build.
You could, right? But the beauty of this is that you don't have to depend on emulation on your Intel device to then run your unit mm-hmm. test or to run your experiments. So you can really just be in the ARM environment.
Right. Okay. And then in terms of the emulation, how heavy is this? Do we find if I run like a game on here, for example, that's designed for an Intel chip, is it going to run really slowly, or is the emulation like lightning quick?
We do see really good performance for our emulator as part of Windows 11, but I don't have the numbers with me or memorized, Jim. There will be some impact. With any emulation, there will be overhead. But something that you can explore as a developer is, and this is really cool, is something that we call ARM-EC. And so ARM-EC, what it is it enables you to start transitioning your application to run native on ARM while still keeping parts of the application to be in x64.
Oh, okay. So if I wanted to build something to run on x64, I'd have to build just an x64 version.
Right.
But if I want to build something to run on ARM, if I've got my monolithic application with how many different bits and pieces in there, I don't need to port them all over to.
Correct.
I can just port just the bits over, and in one binary I can have just the bits. Okay, so if I'm bringing a binary from someone else, I can kind of mix and match that. So I've got a bit more power. Okay.
So it gives you the flexibility of not needing everything to be native before you can actually give out your application to other people to try, or customers, right?
Yeah. Okay, so can we actually see it in action?
Yes.
Okay, so launching Visual Studio.
Yeah.
Well, this is the same Visual Studio, I'm guessing.
Yes, so this is a typical Visual Studio install that I got from our public site. And so what I'm doing now is I'm going to create a Windows desktop application that is using native C++.
Okay.
And I'm going to call it Volterra since I love the name.
It is an awesome name.
Yeah.
So you're using C++, but I assume things like .NET would work if someone wants to create like a C# project.
Absolutely.
All that stuff would just work.
Yes.
Yeah. Okay.
It all comes, all of the ARM tools come from Visual Studio when you install the different workflows that you need to work on. Like
and they will just work.
.NET, they would just work.
Nice. So is C++ your jam? Is that where you live?
Yes. And so I've been doing C++ development for a long time now, since I started at Microsoft. And so there's another tool for C++ developers that I'll talk about at the end there.
Okay.
That I love, and something that I worked on for a very long time. Cool. And so, this is a typical, project. Okay.
Yeah, it looks
it's
fairly
empty.
Standard. You've got your
right?
H instance, and wow, it's been ages since I've done any C++ development for.
Yeah, and so this is a empty framework for building a Windows desktop application, and you can see up here where you typically pick your target. We have ARM64, x64, and x86.
So normally it's just x64, x86.
Right.
But we've got ARM64 there, so we can build for all three.
Exactly. So now I can come here and I can say build, and it's going to go and build this project for ARM64. So let me go and show you what it looks like. If I were to do the typical workflow, I'm going to debug while I'm going to run while I debug in Visual Studio, and this is what we have. It's just an empty frame or empty window. Yeah. So one thing that I would like to show you is how do we see that this is running ARM? We can come here to the details, and I'm going to type Volterra, which is our app, and you can see here under architecture, this is running ARM64. Right?
Okay, so that's running. But I'm noticing that there's one below. There's an x64. I'm seeing x86s. So it is running.
Yeah. So there are components.
Yeah.
So there are components in this image that are running in the varied architectures running under our emulation.
Nice. And we can do. You're saying we can do the same thing with the app you just built.
Yeah. So look at this.
I want to see this.
So I'm gonna change it. Build x64. I'm gonna build with a new target. You see we succeeded. I'm going to run it. This is a new Volterra instance of the app, right?
Yeah.
And then I'm going to come back and I'm going to look for Volterra again. And you can see now that this is running in x64. So this is running on top of our emulation layer, and you can run your tests, you can run your unit test, and everything that your typical developer workflow looks like.
Okay, so I could actually take, if I've got a whole unit test suite, if I'm doing something really low level where I'm actually thinking about maybe registers or maybe running something that I might really want to stress test on both, I can do that. I can run my unit tests on x64, x86, and ARM. If I've got anything that thinks about the memory sizes, for example, x86, obviously 32-bit integers and 32-bit registers. ARM64, this is 64-bit registers. If I'm getting to that low level, I can still do all this.
You can still do
it,
yes.
Nice. This is really, really cool stuff. I mean, this is just amazing just how much cross-platform you're getting.
Yes.
Just from one place. And as you say, I could use this one device to build it, and then I can deploy to whatever platform I want. I can build the different versions. If I'm deploying to the cloud, I can have the different versions.
Yeah, let's touch a little bit again on that NPU power that comes with these devices.
So that's the neural processing unit, the AI brain that's in there along with the GPU and the CPU. Yeah.
Correct. And so now you can start building your applications and integrating those workflows. And
so I can build like an AI application.
You can build your models, right? Yeah, so how do you do that is you use the ONNX runtime. And the ONNX runtime is enabling you to build your application with the abstraction layer of the hardware, which means you can build your application targeting this runtime. And as different NPUs come to the market, your application will be able to still run your models into different devices.
Okay, so not only are we able to build for different CPU architectures on here, but also I could build using the ONNX runtime. I could build for different NPU architectures. I could build something and I could test it on, I guess, the NPU here, but also I suppose the GPU and CPU if I wanted to.
You could target,
and then I can then take that and deploy that to like a cloud workload running on whatever hardware's in the cloud. I could deploy it to like NVIDIA Jetson range of devices. So this is kind of like the one device for building them all.
Exactly. So that is why this device is so cool, is it gives you all of the hardware and support that you need to start targeting a bunch of different devices and future devices with the frameworks that we're putting into place. And so we will be talking more about what does that cloud integration looks like when build comes this year.
Okay, that's in May this year, isn't it?
Yes.
So, okay, so that's quite exciting then,
yes.
because this idea of I can build for so many different platforms in one place, which is why this is a dev kit, because as a developer, I want to build for multiple platforms. We've got that here, and there's kind of more exciting things to come. Cool. And I do have to ask you one question. I do have to ask you one geeky question.
Go ahead.
So I know in the past you've been involved in some very cool projects. I hear you're involved in the time travel debugging that allows people to kind of rewind time and debug, which is an absolutely epic thing. Does that work on this? Can we do time travel debugging on both ARM and x86 on this?
Yes, Jim. Very, very soon, you should be able to download WinDBG, the store app, and get time travel debugging for native ARM debugging. And so time travel debugging is awesome. I love it. Worked on it for many years, and it's really a cool developer tool. And you have it for x64 and x86, and it is almost there. So I've had the pleasure of trying it myself internally, and I know that it's going to be available to the public very soon.
Nice. So it's literally the point where anything you can do on the x86, x64, you can do on ARM as well.
Yes.
Which opens up the whole world for you, because this is not about we're saying goodbye to Intel. It's not like that at all. No, it's we want to target both, because both have their upsides and their downsides. This gives you that chance to choose the best hardware for what you want to do.
Exactly. And so as a developer, you're able now to build for all of your customers, the people that love your products, and doesn't matter what architecture they're choosing on what device that they're running, you're able to target all of them. And so that's really cool.
Awesome. Okay, and if someone wants to get their hands on one of these, I mean, this is not just a special Microsoft-only device.
Nope.
This is, you can buy this.
Yes, so you can go to our Microsoft store and you can order one of these today.
Nice. Awesome. Well, thank you very much. It's really great to have you here in the reactor. Thank you for showing off this device. This is very exciting. I'm going to try not to steal yours, but I might have to get on and order one myself. Thank you so much.
Yeah, awesome. Thank you for having me, Jim.
As cool as this project is, what's even cooler is you can recreate this at home. Check out the link below for everything you need.